The chemical compound potassium chloride is a metal halide salt composed of potassium and chloride. It is odorless and has a white or colorless vitreous crystal appearance. The solid dissolves readily in water and its solutions have a salt-like taste. Potassium chloride is used in medicine, scientific applications, food processing, and used to cause cardiac arrest as the third drug in the three-drug cocktail for executions by lethal injection. It occurs naturally as the mineral sylvite and in combination with sodium chloride as sylvinite. Chemical properties. Solubility. Potassium chloride is soluble in a variety of polar solvents. Solutions of potassium chloride are common standards, for example for calibration of the electrical conductivity of solutions, since potassium chloride solutions are stable, allowing for reproducible measurements. In aqueous solution, it is essentially fully ionized into solvated K+ and Cl ions. Redox and the conversion to potassium metal. Although potassium is more electropositive than sodium, potassium chloride can be reduced to the metal by reaction with metallic sodium at 850 degrees Celsius because the more volatile potassium can be removed by distillation. Potassium chloride plus Na sodium chloride plus K. This method is the main method for producing metallic potassium. Electrolysis fails because of the high solubility of potassium in molten potassium chloride. Physical properties. The crystal structure of potassium chloride is like that of sodium chloride. It adopts a face-centered cubic structure. Its lattice constant is roughly 6.3 A. Crystals cleave easily in three directions. Some other properties are transmission range 210 nanometers to 20 micrometers. Transmittivity equals 92% at 450 nanometers and rises linearly to 94% at 16 micrometers. Refractive index equals 1.456 at 10 micrometers. Reflection loss equals 6.8% at 10 micrometers. dN/dt equals minus 33.2 times 10⁻⁶ degrees C. dL/dt equals 40 times 10⁻⁶ degrees C. Thermal conductivity equals 0.036 with damage threshold 4 gigawatts per square centimeter at 2 J per square centimeter, 4.2 J per square centimeter. As with other compounds containing potassium, potassium chloride in powdered form gives a lilac flame test result. Production. Potassium chloride is extracted from mineral sylvite, carnallite, and potash. It is also extracted from saltwater and can be manufactured by crystallization from solution, flotation or electrostatic separation from suitable minerals. It is a byproduct of the production of nitric acid from potassium nitrate and hydrochloric acid. Barratry methods. Potassium chloride is inexpensively available and is rarely prepared intentionally in the laboratory. It can be generated by treating potassium hydroxide with hydrochloric acid, Co plus hydrogen chloride, potassium chloride plus H2O. This conversion is an acid-base neutralization reaction. The resulting salt can then be purified by recrystallization. Another method would be to allow potassium to burn in the presence of chlorine gas, also a very exothermic reaction. 2K plus Cl2 potassium chloride uses. The majority of the potassium chloride produced is used for making fertilizer, since the growth of many plants is limited by the potassium intake. As a chemical feedstock, it is used used for the manufacture of potassium hydroxide and potassium metal. It is also used in medicine, lethal injections, scientific applications, food processing, and as a sodium-free substitute for table salt for persons concerned about the health effects of sodium. It is sometimes used in water as a completion fluid in petroleum and natural gas operations, as well as being an alternative to sodium chloride in household water softener units. Potassium chloride is useful as a beta radiation source for calibration of radiation monitoring equipment, because natural potassium contains 0.0118% of the isotope 40K. 1 kilogram of potassium chloride yields 16,350 becquerels of radiation consisting of 89.28% beta and 10.72% gamma with 1.46083 MeV. Potassium chloride is used in some de-icing products that are designed to be safer for pets and plants, though these are inferior in melting quality to calcium chloride. It is also used in various brands of bottled water, as well as in bulk quantities for fossil fuel drilling purposes. Potassium chloride was once used as a fire extinguishing agent, used in portable and wheeled fire extinguishers. Known as Super K dry chemical, it was more effective than sodium bicarbonate-based dry chemicals and was compatible with protein foam. This agent fell out of favor with the introduction of potassium bicarbonate dry chemical in the late 1960s, which was much less corrosive and more effective. It is rated for B and C fires. Along with sodium chloride and lithium chloride, potassium chloride is used as a flux for the gas welding of aluminium. Potassium chloride is also an optical crystal with a wide transmission range from 210 nanometers to 20 micrometers. While cheap, potassium chloride crystal is hygroscopic. This limits its application to protected environments as short-term uses such as prototyping. Exposed to free air, potassium chloride optics will rot, whereas potassium chloride components were formerly used for infrared optics. It has been entirely replaced by much tougher crystals such as zinc selenide. Potassium chloride has also been used to produce heat packs which employ exothermic chemical reactions, but these have mostly been discontinued with the advent of cheaper and more efficient methods, such as the oxidation of metals of the crystallization of sodium acetate. Potassium chloride is used as a scotophore with designation P10 in dark trace CRTs, e.g., in the skiatron. Biological and medical properties. Potassium is vital in the human body, and oral potassium chloride is the common means to replenish it. Although it can also be diluted and given intravenously, it can be used as a salt substitute for food, but due to its weak, bitter, unsalty flavor, it is usually mixed with ordinary table salt for this purpose to improve the taste. The addition of 1 ppm of thiametan considerably reduces this bitterness. Complaints of bitterness or chemical or metallic taste are also reported with potassium chloride used in food. Medically, it is used in the treatment of hypokalemia and associated conditions as an electrolyte replenisher. Brand names include K-Dur, Chlorcon, Micro K, Slow K, Sando K and K-on-Cl, most of which are extended-release oral medicines, with a molecular weight of approximately 75 and a valence of 1. The use of potassium chloride for electrolytes makes 75 mg the equivalent of 1 MEq. Oral and intravenous doses for adults are typically in the range of 8 to 20 MEq, which is 600 to 1,500 mg of potassium chloride. Side effects can include gastrointestinal discomfort, including nausea and vomiting, diarrhea, and bleeding of the digestive tract. Overdoses cause hypokalemia, which can lead to paresthesia, cardiac conduction blocks, fibrillation, arrhythmias, and sclerosis. Because of the danger of hypokalemia, the US FDA limits the amount of potassium supplements to 99 mg while recommending an adult daily intake of 4,700 mg. Prescription potassium citrate can be prescribed as an alternative to potassium chloride. Slow-K is a 1950s development where the medicine is formulated to enter the bloodstream at delayed intervals. It was first only prescribed to British military forces to balance the diets while serving in Korea. Some cardiac surgery procedures cannot be carried out on the beating heart. For these procedures, the surgical team will bypass the heart with a heart-lung machine and inject potassium chloride into the heart muscle to stop the heartbeat. The lethal effects of potassium chloride overdoses have led to its use in lethal injection as the third of a three-drug combination. Additionally, potassium chloride is used in fetal intracardiac injections in second and third trimester-induced abortions. Jack Kevorkian's Thanatron machine injected a lethal dose of potassium chloride into the patient, which caused the heart to stop functioning. After a sodium thiopental-induced coma was achieved. Precautions. Orally, potassium chloride is toxic in excess. The LD50 is around 2.5 grams per kilogram is about 190 grams. The oral toxicity of sodium chloride is about the same, 3.75 grams per kilogram. Thus, potassium chloride is harmless for alimentation, but intravenously, without the step of digestive absorption, this is reduced to just over 30 mg per kilogram. Most concern are its severe effects on the cardiac muscles. High doses can cause cardiac arrest and rapid death. Thus, the aforementioned use as the third and final drug delivered in the lethal injection process.